Hey, ladies and gentlemen, this is Mr. Anderson. In our first nonlinear algebra digital distance lesson of the year, we're going to be going through some material from the appendix in our CPM book. And I've got a Schoology course open. At this time in my Schoology course, this is where we have access to that CPM ebook. So if you want to follow along in your ebook, you will have had to create an account at this point. It is pretty straightforward. You do log in with Google, but you're going to need that code from your teacher if you haven't gotten that. So you can click here. Otherwise, you can follow along with me as I'm going to go through some notes on the screen. So remember, this is a video. It is not live. You can pause. There are times when I'm going to ask you to pause. So please take advantage of that. Pause, think, stop, play, write things down, etc., etc. Okay, our goals today are going to be to talk about what a variable is, and we're going to be ending with some combining like terms. Okay. First and foremost, you can read some of the material here, but this is a review lesson from some of the pre-algebra material that you've covered prior to this nonlinear algebra course. And what we're going to be doing today to investigate these things is we're going to be using some things called algebra tiles. Now, we're not in person. We don't have these things hand in hand, so we've got to have a little bit of a workaround. I'm going to show you what that is here in just a moment, okay? These unknown quantities that we talk about, I'm sorry about my circling there, these unknown quantities that we talk about often in math classes, those unknown quantities do have a name, and that name is a variable. Now, the reason that text is in blue is because when you click on it in the ebook, it will define it for you. It's got a nice little bump out definition. Check it out. Okay, we're going to check out algebra tiles that are going to help us investigate the idea of a variable. Okay, we don't have this bag or set of algebra tiles, so we've got to use these e-algebra tiles. Check it out. All right, we've got this link in the book. It says, alternatively, electronic algebra tiles are available here. So if you click that link, this is what it's going to pull up. I'm going to change the window here. We've got something that looks like this. Now, you may have seen something like this before, but we've got a couple different variations, all right? We've got a unit tile. This is a 1x1 tile, and we've got an X tile and a Y tile. I'm going to have you guys notice a couple things. I double-click, it'll rotate them for me. Double-click, it'll rotate them for me. Check it out. Are X and Y the same? All right. If I dump that in there, are X and Y off by 1? How many are X? How many are Y? Do we know these things? Okay, start thinking about some of those big ideas, right? We can select multiple algebra tiles at a time. We can move them. We can rotate them. We've got tiles that are bigger, tiles that look like this. I've got a tile that I can do that with. I can do this with it, right? There's quite a few options for what we can do with some of those tiles there. We'll go back to them in just a second. How many different shapes can you find? Well, I think we saw a unit tile, we saw an X tile, we saw a Y tile, we saw an X by Y tile, and we saw an X squared and a Y squared. I think there were, oh my goodness, my iPad, there we go. I think there were 7 total different tiles. How are the shapes different? How are they the same? Some of them had the same dimensions. Okay, but how were they all different? They all had different areas. Okay, and that was the really cool part about these algebra tiles. We saw that, right? Like, for example, this Y, if I flip it and rotate it, has the same dimension there and there. Okay, but notice, it's not going to work here and here. All right, well, I can put it on this one, and I can put it on that one. Well, it doesn't fit on that one. Interesting. You may have noticed that when I click it just one time like that, it goes and it turns it red into a negative Y. We don't need to worry about that right now. We'll get there, but we don't need to worry about that yet. Okay? I'm going to kind of gloss over part of number 2, but I think after seeing that little description there, you might be able to answer this question: which fit together and which do not? And if we can start to connect why they fit together, that's a pretty gosh darn powerful thing, okay? What about them makes them fit? What about them makes them different, right? That's a good comparison tool. How are they the same? How are they different, right? We're going to pass by the drawing a picture of each one of these on your paper. I'm not going to do that. If you want to do that, you are certainly welcome to do so. But a valuable thing maybe would be to take the screenshot of some of these things sitting here, okay? But our goal is going to be to jump into some of these activities below here, right? One of the things I failed to mention, and I'm going to come back to right now because it's worth talking about, is how CPM organizes their work, okay? This right here says A-1. This right here says A-2. The A stands for the appendix. So when you click into our CPM ebook, you're going to see here that we are in the appendix, and we happen to be in the first section. Notice, I just took these notes right out of the first section here. All right? And the other thing that you're going to find here is that we're in A-1. This is the first problem of the appendix. This right here is the A-2, the second problem of the appendix, and we're about to get into the nitty-gritty of it here. All right? The algebra tiles are referred to by their areas, right? So we name these things using the areas. So this one right here, this is an x squared tile because it's got an area of x squared. It is x by x. It's an x squared tile. Oops, not negative x, sorry. Okay, it's an x squared tile. This is a y squared tile because its dimensions are y by y. This right here is called an xy tile. Can you guess why? Right? Because its dimensions are x by, you probably got there before me, x by y. This right here is a unit tile or a 1 tile. Why? Because how wide is it? 1. How tall is it? 1, and of course 1 times 1 is 1. That's how we name all of those algebra tiles, right? The smallest is one unit, right? It can also be called the unit tile. You see that here in A-2 part A. Can you use the unit tile to find the lengths of the other tiles? That's one of those things I led you with, okay? Can we somehow, can we somehow do this? Can I plug those on there? And how long is that X tile? And do you know for sure? Why do you think so? Why or why not? Pause this video. Pause it and see if you can write down an answer. Okay? Then go ahead and just jot down the names. I'm looking at part B now. Go ahead and pause the video. Jot down the names of the other tiles. Okay? Remember, the area for our, parallelograms. Something we probably picked up in 5th, 6th, 7th grade. Length times width, base times height, however you want to refer to that. We're going to use those length and width measurements to identify those shape names, okay? If you need more time, again, you can pause this video at any time. Moving on to the third question here. It says your teacher will show you a jumbled pile of tiles. All right? And I'm asking you to name them. What is the best description for the collection of tiles? Is your description the best possible? Now, here's what I'm going to ask you to do. Go ahead and make sure you can identify them all. Pause the video and try to write down a description of each one. I'm sorry, a description of them all together. All right? And if you can do so, then unpause the video. I'm going to pause it right now and I'm going to write my description down. I want you to do the same thing. All right, we're back. Did you pause it? Let's see how you did. I've got some stuff written on the screen here, and I want to check it out with you, and hopefully we can maybe find a little clarity here. Let me slide this off just to kind of diagram some of this. I've got 2x squared and 2x, right? Where do those things come from? Well, I think the 2x squareds, I'll try to connect right here, right? There's 2 of those, so I'll put them together because those shapes match. And then I've got 2x, I got one of them right there, and my lines are going to start to get a little messy, right? There go those things. I've got 2x squared and 2x. Okay. And then I've got a y squared. My y squared is right there. There's just one of them. And then I've got 2 y's. There's one there. There's one there. Okay, looking good so far. And then I've got that, little blue 4 down there. Here's one. Here's another one. Here's one more. and here's one more, right? So all those things can go together because all those shapes match. They're combinable, right? They got the same area, they got the same size, they got the same shape. But now check this out. They're all in different colors, I think we can see. However, they're not all the same, right? Remember, taking those shapes and goofing around with them on that E-tiles activity, we couldn't line those things up, all right? And that's why we can't put them together algebraically either. That's why I need to write the x squareds and x's separate from the y squareds and y's separate from the units, okay? So down here in the black rectangle is the simplest expression that I can have for this jumbled pile of algebra tiles, right? How'd you do? Did you get it? If not, we're going to have an opportunity to try another one, okay? Little backwards design now. We've got a couple algebra tile configurations here, or excuse me, expressions that we're going to build a configuration out of them. So here's what I'm going to ask you to do. I'm going to ask you to build one with me, and I'm going to ask then you to try another one on your own. The one that we're going to build together is going to be A. All right? Now, I'd like you to pause the video. I'd like you to go to that E-link, that E-algebra tile link, and I'd like you to try to build A. I'm going to pause it, I'm going to build it, and then we're going to come back together and we're going to check it out. All right, folks, I'm back with you. I built A. You want to see it? Hopefully you did as well. Let's check it out. I've got 3x plus 5 plus x squared plus y plus 3x squared plus 2. Okay? Now, ladies and gents, I went ahead here and oops, you know what? I made a mistake. Gosh darn it. Okay. Man, it's almost like this was calculated. Check out what I can do with these algebra tiles. I can drag those things off the screen. Okay, I'll put a 3x squared. See, I mistakenly put a 3y squared there. Let's put the 3x squared back. Okay, check it out. Now I've got that thing built correctly. 3x plus 5 plus x squared plus y plus 3x squared plus 2. Now here's the question they ask. All right, is it possible to simplify the expression? And here's what I want you to think about. If it's possible to simplify the expression, we're going to be able to put some of these items together in matching piles. Look at this. This is what combining like terms is all about. Look at that. We're simplifying expressions. Now what do we have? I'm going to show you in a second. I've got a 3x right here. I've got 1, 2, 3, 4, 5, 6, 7 right there, so 3x and 7. 1, 2, 3, 4 x squared, and then I've got a y standing there all by itself. And as I go back to my notes, that's exactly what we've got right there. That's what combining like terms is all about. We're taking those pieces that match and we are putting them together. And here's my challenge to you. Pause the video, try B, C, and D, and see if you can combine some like terms. If you'd like, use the algebra tiles just like we did. If that makes the process easier, there is no need to make this process strenuous on you, okay? Then when you've unpaused the video, when you've gone ahead and you're ready to move on, I'm going to have you tackle two things. The first is going to be something we're going to call a learning log. Now we're trying this the first time very, very informally. All right, we're going to generate a learning log, and you are going to do this thing in your notes on a blank sheet of notebook paper, and your job is to explain in your own words what is a variable. Okay, and learning logs are helpful because we can then use them on the assessment to help with their memory refresh. And we'll talk about that as we get closer to the assessment. But read this prompt and fire up your learning log. After you're done with your learning log, we've got a bit of an assignment here. All right, a bit of an assignment is a review preview, and it is our homework assignment. CPM calls these things review preview, but we call them homework. It's our formative assessment. It's the opportunity for me to see how you're doing with some of these things. And there are problems 6 to 11, and you find those things in your text. This is why we need to be logged on to that ebook. Sorry, wrong tab. Down under the review preview. Okay, review preview icon, 6, 7, 8, 9, 10, and 11. Some are going to be easy, some might be a little tougher. But check this out. If you need that e-tool, they're there. And if you need a little homework help, they're there. Ladies and gentlemen, get after these things when you're done. Create a Schoology submission and check, look for an updated score. Thanks a ton for watching. Have a great day.